In this video, I'm going to spend time explaining the functionality behind our monitors in further detail. Now, monitors are used in networking, for load balancing and WAF, as well as DNS failover to detect device availability in order to make automated routing changes. In the panel, you'll see the Monitors tab under Cloud DNS, and the same appears under Networking. If you only subscribe to one solution, you'll just see the one, but they are identical. There are several built-in monitors covering a ping check, a TCP check, and HTTP checks. You can't edit them to see the properties, but we've made the name somewhat self-explanatory. If these meet your needs, then we recommend using them. It's easy to create your own custom monitor. When you click Add, you'll be presented with two options, Default or Advanced. If you choose Default, you have 4 options to choose from. All of the parameters are already set. All you need to do is name it and save. If you create an advanced monitor, then you'll be presented with many more options, as well as standard and special configuration options. I won't cover all of the different monitor types today, since many of them are self-explanatory, and we go into them in further detail in the online manual. What I will talk about are the standard and special parameters, since it can be a little confusing. I should note here that if you create a default monitor, you can always go back to edit it and see all of the advanced parameters. For my demo here, I'm going to create an HTTP monitor. This monitor does a check to a URL using HTTP or HTTPS using a head or GET and expects a specific HTTP response code. The interval is how often it checks. The default is every 3 minutes, but I'm going to change this to check every 1 minute. The response timeout is how long it will wait for the URL to return the HTTP response code. The default is 30 seconds, which seems like a long time, so I'm going to drop that down to 15 seconds. And that might even seem a little bit too long, but keep in mind we do check from all corners of the globe, so allow some extra time for that. The downtime is like a resting period. If the monitor detects an outage, we'll wait for this amount of time before starting the monitoring again. So I'll leave it at 30 seconds. The retries is the number of additional checks required to change a device's status. The lowest setting is 1, which means that if we check every 1 minute with 1 retry, it would take 2 consecutive checks or 2 minutes before this device is considered down. Success retries is the number of consecutive checks that are good or positive to bring the device back up again. We give a separate value since many customers want to take devices down quickly but bring them back up with a little bit of a delay to ensure that they are solid again. So I'll leave this value at 3. Failure retries is definitely a confusing one. So 0 means it's disabled, not that it takes 0 retries to take a device down. So a 0 is perfectly acceptable. Right now, since it's disabled, we get 2 consecutive checks to take a device down, as I mentioned a moment ago. And again, the online manual goes into a lot more detail. But the only time you would want to use this is if you don't want consecutive failed checks to take a device down. So for example, if you set your retries to 8, you could set this to 4. So any 4 out of the most recent 8 would be sufficient to consider this device down. I don't need that for my test here, so I'll just leave it at 0. The destination IP should normally be left blank. When it's blank, it assumes the IP of the device you attach this monitor to. You could put an IP here if you wanted to have the failure of one device affect another. For example, with a ping check, you could ping your firewall, and when it stops responding, then all of the devices that are attached to this monitor are considered down at the same time. The destination port is what you want to check, so for HTTP, it would typically be port 80. To make it an HTTPS monitor, you'd change this to 443, and you'd also check the secure box below. Response timeout threshold is a future feature, and action is not applicable for this type of monitor. The custom header can be considered the host header. For example, with this HTTP monitor, when I bind it to my device or specify a destination IP, it would attempt to load a URL with the IP. But if your web server doesn't load on the IP and needs a domain name, you could put that in here. So I'll put in www.example.com. That way, when it makes the request, it will add that host header and properly load my site. Of course, the enable toggle makes it easy to pause monitoring on all devices that use this monitor. Reverse means that it will consider a failed probe good and a successful probe bad. Secure is required if SSL negotiation is needed, so for checking a URL with HTTPS, this is needed, in addition to setting the port to 443 as I mentioned a moment ago. And the LRTM should be enabled if you're doing load balancing using the LRTM method. On the Special Parameters tab, you'll find additional options. Now, for this HTTP check that I'm setting up, you can specify the request type and URL plus the accepted responses. Here, it's set to a head request towards the root URL. And we can change that to load a specific page behind a specific directory if you like. And we can change head to get if you prefer. Head just requests the headers, where get loads the entire page. So if page load time is important in determining if a device is available or not, you might want to change that. Here it defaults to accepting a 200 response code, which is certainly the most common, and of course you can add any other type that you want. For my test here, I'll add an HTTP 302 as well. You'll see that for other monitor types, the special parameters are different. For example, the HTTP content allows you to look for content on a page. It can look again for a specific URL and then look for a word on the page. For MySQL, I can specify a database, and for other checks like TCP, there are no additional options. So I'll just keep it as the standard HTTP check for now, and I will save this monitor. And now it's ready to attach to your devices, either in DNS failover or a server in networking. And that's it. Of course, I've only scratched the surface on monitors. I do highly recommend checking out our knowledge base or the online manual to learn a lot more.